Hey guys, sorry I couldn't be with you today. I'm still having some issues recovering, walking with a cane. So I miss you guys a lot, but hoping to be in there on Wednesday. Um, just wanted to go over a couple of the new IXL assignments that I have given you for the day. Two more. So you have four for this week, and the two from yesterday are for part two of 2.3, and this one will be for part one of 2.4. Okay, and this covers the rational root theorem, okay, which is like a continuation of finding factors of polynomials, usually using synthetic division. All right, so you should, probably I think we covered it a bit. The rational roots theorem that says, let's say I have some polynomial. I'm just making this up. Like x4 plus 3x squared minus x plus 7. Okay, the rational roots theorem says that the possible zeros of this polynomial, there's a lot of things it could be, right? Like x-intercepts. There's a lot of zeros it could have, but it's not an unlimited amount of zeros. In fact, the zeros you could possibly have is positive or negative b over a. This is how it's usually notated, where the constant is the b, okay, and this coefficient here is the a. So this would be a fairly easy one to figure out, right? Because your only possible uh, roots would be, well, what are the factors of 7? 1 and 7. And then what are the factors of 1? It's 1. So the zeros of this thing could be 1 over 1, 7 over 1, -1, or -7 over 1. All right, those are the possible real zeros you could have. That doesn't, or real rational zeros. That doesn't mean that there might not be some other imaginary solutions, right? So then this over here, um, according to the root theorem, which of the following are possible roots? So this is saying the leading coefficient is 5, right? That's your a. Okay, if I go back to this, your a is 5, and the constant term is -7. So then this would be positive or negative b over a, right? Where a could be positive or -1 or 5. And the b could be positive or -7 or 1, right? So what could you have here? You could have 1/5, -1/5. You could have 7, -7, 7/5, -7/5. This says, which of the following are possible roots? What did we say? 7/5 and 7, right? 7/5, 7 and 1/5. 1/5's not on here. 7/5 and 7, right? Yeah, forgot about 1. Don't forget about 1, right? 1 and 1. I did that on purpose as an example, okay? Obviously. All right, let's look at the next one. We'll do this one more and then we'll do the other assignment, okay? So, for example, here it says the leading coefficient is 1, okay? The leading coefficient is 1. Okay. Which would be A, right? So that's just the 1 down here. And the constant term is -2, so that's 2 and 1. So what are the possible rational roots? I don't like that. They should say rational roots. Um, so what is it? 2 over 1 and 1 over 1. Or -2 and -1. That's it, right? And okay, I guess we'll try one more. Gotta redeem myself here. So let's see. Leading coefficient of 2, which again is the A, right? So that's positive or -1 or 2. And the constant term is -7. So the factors of -7, positive or -1 or 7. So I could have 1 over 1, 1 over 2, 7 over 1, 7 over 2, right? So 1 over 2, 7 over 2, and -7. See that? Because 7 over 1. So all three of these. Okay, does that make sense? Let's go look at the other one real quick. Quickly get over there. I'll show you the fastest way to do it. Here we go. Okay, the other assignment, Descartes' rule of signs. All right, so you probably remember this being mentioned in Algebra 2 last year. So this is kind of, again, like an outdated theorem, but it's kind of neat, and so we're just going to do it. And you'll probably see this as like extra credit on a quiz. So the Descartes' rule of signs tells you about the types of real zeros you can have, okay? So not counting the imaginary solutions, but Descartes' rule of signs tells you about the real ones. There's two rules, actually, okay? There's a rule for the positive zeros and the negative possible zeros. So in this example, what I'm looking at is how, see how it's called the rule of signs? I'm looking at how the signs change. So for this one, I'm saying, how do I go from, this is a positive to a positive, so no sign change. Positive to a negative, that's one sign change. Negative to a negative, that's not a sign change. Negative to a positive, that's two sign changes. So since there's two sign changes, that tells me that there could be two possible real zeros or this number minus 2. So there could be 2 or 0 real positive solutions. So is it possible to have 0 positive? Yes, I just got 0. 2 minus 2. Okay? Here's another 2 positive. So when it says 2 positive reals, all you do is take the polynomial as it is and count the sign changes. All right. So again, I'm just going to write the signs this time. So positive x cubed, positive 2x squared, positive 2x, and positive 2. Are there any sign changes? No. So that tells me 0. 0 sign changes means there's 0 positive real zeros. So could there be 2? No, because there are not 2 sign changes. Okay. I'm wanting it to give me a negative. So let's see. How many sign changes? 1 sign change. So could it have 2? No, there's only 1 sign change. Okay, positive again. Could there be 4? Well, if it's going to have 4, there ought to be 4 sign changes. Or 6, right? 1 sign change, only 1, so no. Here we go, the negatives. Now, for the negatives are more fun. Okay, to check the negative real zeros, which, you know, if this was a polynomial out in the wild, you would have to do both of these, all right, if you're checking each one. You would have to check, not f of x, but you're checking f of negative x. All right, now you're checking the sign changes for an f of negative x, and sometimes they won't change. So like, everywhere I see an x, this tells me to put a negative x. So I'm putting a negative x here, plus 7. And so maybe you might be thinking, well, why can't I just change them all to negative and be done? Because you sometimes finish writing this. It's taking a lot of concentration. Okay. So sometimes when you have a negative x being raised to a positive even, don't know why I said positive, even radical, okay, that will become a positive, right? So this would actually be x6. This is staying a negative, so that's minus 7x5. This is becoming positive, then being multiplied by a negative, so that's negative 9x4. This is staying negative, right? Because it's an odd exponent, and this is a negative times a negative, so that's a positive 3x cubed. Okay, this is a positive times a negative. All right, now this is f of negative x. That's what I have here, f of negative x. And I'm counting the sign changes again. Positive to negative, that's 1. No change. That's a change. That's 2. That's a change. That's 3. No change. 3 sign changes. So there could be 3 negative real roots or 3 minus 1. I'm sorry, 3 minus 2 equals 1. There could be 3 or there could be 1 negative real roots. What's the question say? Could it have 0? No, right? You can only have 3 or 1. You can't have 0. So we're going to say no. Okay, does that make sense? This is in your book. You can check it out. And hopefully you'll be able to finish these assignments in class time. And also remember that if you're just like 85, 90, That's good for your grade, but you should not be quitting in the middle of class on this assignment unless you have 2 100s, right? Okay, so I look forward to seeing you guys, Lord willing, on Wednesday. Have a good day.